अस्सलामुअलैकुम एंड बिस्मिल्लाहिर्रहमानिर्रहीम। आप लोगों के लिए लेक्चर देना तो आजकल जान को ख़तरे में डालने के बराबर ही है, यूनिवर्सिटी से ख़ास तौर पे। तो टुडे वी विल बी टॉकिंग अबाउट सेंटिमेंट एनालिसिस एज अ स्पेसिफिक केस ऑफ टेक्स्ट क्लासिफिकेशन। ठीक है, तो लेट मी शेयर माय स्क्रीन। So today's topic again is sentiment analysis. So a buzzword that you may have already heard of in data science or data mining. So this is a specific case of text classification technique. Text classification task to determine the positivity or negativity of a particular piece of text. Say, for example, in product reviews, and these online retailers are concerned about how their products are being reviewed, and these reviews matter in terms of future uh, marketing and how they need to reorganize the business. Okay? Similarly, politics, what happens in the elections does reflect the general views of the public, and public sentiment is important, and many other things. Okay? So where are these being used in general? For example, let's start with simple restaurant reviews. For example, let's say you have a review that says food was tasty, service was awful, exclamation. ठीक है, तो how would you how would you say that this is a positive review or a negative review? So this word is positive, tasty, awful, negative. So would you rate it as a neutral review of sorts? And then there is another issue of the food being related to tasty and service being related to awful. So these things are known as aspects. See, service and food. So then we can somehow look at ke in the aspect of food, this review is positive, and in the aspect of service, this review is negative. So maybe we can even combine these things to generate star ratings for the restaurant or something like that. ठीक है? Then there is another trending thing in terms of Twitter sentiment, obviously, which Twitter uses more than you use. But this can be used for many reasons. For example, I gave you the example of politics, trending, Twitter trends, and the kind of sentiment that people are showing on Twitter can predict or can be used to predict election results, and also even predict or manipulate stock markets. Right? So recently, there was this GameStop issue that you should look into. They use the social media heavily, how to manipulate the stocks, and Elon Musk has been using social media and specifically tweets to manipulate the or hype up the price of Bitcoin and Doggy Coin. Then you may have also heard of Cambridge Analytica. This was a scandal that was raised a few years ago, uh, which actually extracted sentiments from of users, and they used this for targeted campaigning, and they have been accused of actually manipulating elections by manipulating people to vote differently, or targeting them with different or person specific advertisements to change their opinion. So these are some very difficult areas, because some of these cross the red lines. So you need to be careful of what you're trying to do with sentiment analysis. And sentiment analysis is actually a small piece of a bigger, or lies under a bigger umbrella called effect analysis. And I'll give you just a brief overview of what effects are. So, for example, emotions come under effect, not exactly sentiments, but these are brief organic feelings. Okay? So, for example, you can say anger is an emotion, but not exactly sentiment, sadness, and perhaps it is joy, fear, shame, and so forth. So these are brief organic feelings that appear in a person for a small period of time, and uh, they show through words or our expressions and so forth. See? The mood, slightly longer duration of feelings as compared to emotions, and mood can be classified as being cheerful, gloomy, depressed, and may last for sometimes even days. Right? Restless, and so forth. Okay? Then there are even longer term things that can be classified, such as relationships, which can span over months or years. Okay? So these are effective stance towards other people. So these relationships can be classified as being friendly, cold, cold relationships like the Cold War, warm relationships, supportive, or distant relationships. Then there are attitudes, and this is where perhaps the sentiment that we think of in terms of NLP lies. Although all of the rest can also be classified using NLP techniques, but they can only be partially classified. So attitudes are dispositions towards objects or people. So these attitudes might involve liking, um, Liking, uh, hating, loving. So all of these have some sort of symbols in your social media. So this is a liking. You can say a thumbs up, hating thumbs down, loving a heart, and so forth. So these are the kind of sentiments that we are probably trying to classify using sentiment analysis. And then even longer term inherent uh, qualities or characteristics of personality that can also be listed amongst the effect analysis. So these are behavioral tendencies. So this is where we are getting into the intersection of social science, how social scientists look at a person through their emotions, how they use their emotions in their speech, in their writing, and so forth. So personality can be nervousness, uh, or just a nervous, I should say, nervous personality, anxious, IOUS, hostile personality, or can be jealous personality, and so forth. Right? So, in general, what we are looking at in terms of sentiment analysis is attitude classification, or it would best fit here. And there are different types of attitude detection. So there are different levels at which this sentiment can be calculated. So in the simplest form, it can be just positive and negative. See, as we saw in the earlier reviews, okay, we can just classify sentiment as being positive or negative. A more complex form would probably do an intensity of how intense. So let's say positive, negative. We are saying positive is a 5 and or 5-star rating, and a total negative is, let's say, even 0. Okay? So bad review would be, very bad review would be 0 stars or 0 rating, and good review would be 5 stars or uh, best rating. And even there are some more advanced ways of calculating sentiments, looking at aspects and more complex attitudes. See, aspects plus more complex attitudes, and then you have ways of combining these things together to get a sentiment or some sort of a metric for calculating sentiment. Okay. So given that, let's go back and see what we did in naive Bayes for classification, and the same thing can be done for sentiment. So let me just review this a bit. So the best class that we were looking at for naive Bayes was essentially the argmax over all the classes from the set of classes C. Then we were saying, okay, let's look at the probability of this class C and multiply it with the product of the features, which are words in given the likelihood of words given a particular class C. So these are positions of words. So I belonging to all the words in the given text. See? So what was this here? This is the prior, and this is saying. So let me just write it down. Okay, how likely are we to see a review of class C? See? So this C, how likely are we to see a review of class C? And this is the likelihood probability, which essentially says, okay, how likely is the word WI uh, to be used in a review belonging to class C. ठीक है. So let's say class C is positive, and we have only two classes, positive and negative. So here we are saying what is the probability of a positive review. So depending on how many reviews we have in our training set, if 60% of the reviews in the training set are positive, then we would say the prior is 0.6, okay, or 60%. Similarly, if for every word we have a separate language model for each class, and we would say, okay, what is the probability of this word belonging to this class, which we were calculating by, for each word, we were calculating this probability and saying what is the count of this word in class C plus one for smoothing, and then we were counting the number of words in all of the text in class C and adding the size of the vocabulary to it. See? So today I'm going to look at a slightly different version of this naive Bayes, which is called the Boolean version of the multinomial naive Bayes. See? And we'll be using this for sentiment classification. Although can be used for any type of classification, but we are looking at sentiments in particular. So, what do we have? We would have the vocabulary. So we would have a corpus. Right? So let's say there's a corpus. We have of reviews. So let's say we have a corpus of reviews, and this is supervised classification. So basically we have review 1 and we have the associated class C1, and let's say we have review 2 all the way to review n in our training set, and we have the labeled classes. Okay, where review 2 belongs to class 2 and review n belongs to class n. So then there are similar reviews in our testing data set, and they are labeled as well. So essentially what we have done, we have a data set and we have split it into training and test data. Okay. So what do we do to calculate our priors and our likelihood probabilities for the words? So first, what we do is calculate the vocabulary. We take the entire vocabulary from the training corpus. यानी कि all the unique words that we have, we get a list of these unique words. ठीक है? Then the next thing we go about doing is calculating the two functions, and I'm going to be doing it slightly differently for the multinomial version. So first we need to calculate uh, the probability for each class, say C, and let me call this C of J this time. For there may be multiple classes. So essentially what we are doing is for each C of J in this set C, uh, we are saying text J, we are creating this text J with all text with class C of J. Okay. So we have an array of all these texts containing class C of J. And then we calculate this prior for this class C of J, and that would be the number of texts, or the number of texts in class J divided by the total number of texts. So now we have the prior for each of these classes. So for example, let's say I have, let me do it up here again. So let's say this is, we have three kinds of reviews. So we have positive reviews, negative reviews, and some of these reviews are neutral. And let me call them equal. So they are neutral reviews. So there are three classes, right? So for each class, I'm trying to figure out, okay, what is the prior for each class in this algorithm here. So let's say we have a total of 100 reviews in our training set. 50 of them are positive, 30 are neutral, and the remaining 20 are negative. So that would mean that the prior for the positive class would be 50 over 100. That would be the number of 50 is the number of texts with positive reviews. So that's 0.5. Then the prior for the neutral class would be equal to 30 over 100, and that would be 0.3. And the prior for the negative class would be 20 over 100, that would be 0.2. So now we have priors for all these classes, right? Then the next thing would be to calculate. I think that's the calculating the prior is the same in the multinomial version, Boolean multinomial version, as the earlier simple naive Bayes version. So here is the difference. So now we want to calculate uh, the probability of each word in our vocabulary with respect to how much the with respect to it being in the class CJ. So now we need to calculate these values. In the Boolean version, we remove duplicates from each text. Okay? So essentially, this is what is different from the earlier version. So for each word, WI, and let me be consistent in text J, we remove duplicates. Remove duplicates of WI from this text J. See? So this is where we are just removing duplicates from each text. So essentially, let's say I go back to my review example. So there's a review that says very, very, let me write it, very, very delicious. So I would rewrite that review, update it to remove this very, very, and just put very delicious. That's all this loop is doing. And I wanted to emphasize this because that's the big difference here. And then we do the same thing. We create a document J, which combines all the text in a single document, okay, of this class C of J. So a single document containing all texts in and you can say what we did earlier is all text J. So essentially, you recall, okay, what we did, we created these documents earlier with neutral and negative. and we combined these reviews with the positive and neutral and uh, negative into separate documents. So this would be document positive, document equal, and document negative. Okay? So this is what's happening here. Then we go about calculating our prior probabilities. So for each word, wi, in our vocabulary, we calculate n of I. That would be the number of occurrences of the word wi in document J. Okay. Then uh, we calculate this probability wi for each different class. So that would be the number of times the word appears in that class plus 1 for smoothing, and n is the total number of words in that particular class plus 3. So here I'm leaving a bit of an error in the algorithm so that you can figure that out during the exam. So if you have watched this video, then there would be definitely something on the exam, especially the final exam, that would require you to solve this error in this code that I've given you. So it's not very difficult, but remember what we are trying to do is for each class, we are calculating a different language model for each word. So that language model should contain every word in our vocabulary. ठीक है? So looking at the example that I used earlier as well for training, we used Chinese, Beijing, Chinese, and we said, let's say this is the Chinese class uh, with a positive. Then we have Chinese, Shanghai. This would be the Chinese class. Chinese food, and what we had was Tokyo, Japan, and Chinese. And I don't remember, but I think this was the other class. Let's call it the negative class. So, and we had a test sentence. Let me write that down as well. So this was Chinese, 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 and Tokyo, let's say. So, and we wanted to figure out कि भाई what this sentence belongs to, what class this sentence belongs to. Essentially, what we are doing in the Boolean multinomial version is that we are removing, we are changing this corpus, we're changing the training and the test sets to say okay, the first sentence actually after removal of the duplicates is just Chinese, Beijing. Okay? The second sentence is Chinese, Shanghai. The third sentence is Chinese, food, because there are no duplicates. The fourth remains the same, Tokyo, Japan, Chinese, with the labels remaining the same. And we also update the test sentence to say Chinese and Tokyo. Okay? And then we are going to do the classification in the same manner as we did earlier. Okay? So that's the only difference that we have. And that's what I wanted to emphasize today. There are different variants of this knife-based classifier. One of them is this Boolean. multinomial version. So generally, knife based classifiers or this technique is not good at capturing semantics. And the main reason for it is or for this is because it's using the bag of words assumption. So it really loses the context. So in some cases that context is very very important, even in our sentiment classification tasks. So for that, if we want to use naive Bayes, we need to perform some pre-processing. So what I mean, let me give you an example of what I mean by the loss. So for example, it loses negation, loss of negation. For example, let's say you have this sentence: food was not good, and let's say didn't like the service either. Right? So when you use the bag of words assumption, this not is separated from the good, and didn't is separated from the like. The good and like might be classified as positive. Okay? So the thing is, this can be easily resolved by doing some pre-processing. So when we see a negation coming before an adjective or an adverb, what we do is we convert this, we invert it to the antonym. So not good would become bad, and didn't like would become dislike, or something like that. Okay? So this pre-processing would eliminate these kind of negations, and there are some other errors which are also not catered for in the knife base because of exactly this assumption, which actually connects the words. So not good, there is a connection between not and good, and did not like has a connection, which is lost during the bag of words accumulation. So let's move on to something more specific to sentiment analysis, and that has been commonly used in practical applications. These are sentiment lexicons. And a lexicon is basically a dictionary. So, if you went into NLTK and you did some experimentation or some exploration, you saw that there is a huge lexicon associated with it, which is called the word net. So a lexicon, let me define a lexicon first. So a lexicon is a list of words, and a sentiment lexicon would be specifically a list of words labeled with the respective sentiment. Okay. So it's a dictionary, like we have the dictionary. So for example, uh, we have a word net that contains words and their synonyms. So from word net comes out senti word net. This senti word net annotates the degree of positivity, negativity, and objectivity. So annotates the degree of uh, let me just put the short positivity, negativity, etc., and objectivity. And what does this mean? This means, okay, you have words listed in the senti word net like nice. and you have um, let's say how many, what is the probability of this word nice coming in the positive sense. So that's 0.95. In the negative sense, it's a 0 point zero 0.01. uh, and in the objective sense would be 0.04. Okay? Sometimes in the negative sense it might be used as sarcasm. Similarly, the word nasty would be listed in this centi-word net, coming the probability of it coming in the positive sense, probably 0.001. In the negative sense, 0.99. Perhaps in the objective sense, perhaps 0, right? Or something of this nature. Okay. So, how can we use these lexicons? How can these lexicons be used? So essentially, instead of creating your own language models, you can use these lexicons. So that's part of transfer learning, some of the advanced techniques. But we can see, okay, which words appear in each sentiment class and use the frequency of words in that class. So, for example, let me give you a short example of some reviews. So let's say the Rotten Tomatoes reviews, they created these scaled frequency graphs for specific words. For example, the word good. Let me draw some other words as well. Okay. If I have space. Say, so the word good, and these are labeled, okay, 0, 1, 2, all the way to 10. Say, so 1 to 10. So the word good appears in reviews with so it's like this. Generally appears in reviews with a rating of about 7 at the max, and very little in the reviews which are rated lower. Similarly, the word amazing, it goes this way. My curve is a bit off, but it's like it's the exponential curve. Okay, it's used highest in the highest rated reviews. Similarly, the word great, it's sort of like this. Okay, it's rarely used in lowly reviewed reviews, and highly used in the high reviews. And the word bad, for example, is used this way. Right? Similarly, if you're looking at phrases, not good uh, was highest here and then goes down this way. See? And the word, for example, terrible, used mostly in the negative reviews or lowly rated reviews, and then barely used in the highly rated reviews. Right? So this is how lexicons can be used to figure out, okay, or they would probably give us a good idea of how words are used in the reviews. And just looking at a review and a lexicon, we would figure out, okay, this review is positive or negative regardless of any model that we have trained or not. So these trained lexicons can be used to develop rule-based engines. Now the next question is, how do we go about learning these lexicons? So up till now we have been talking about supervised learning. Supervised learning is essentially that we have a corpus and it's all labeled. So if you're talking about reviews, we have review 1, it's labeled, review 2, it's labeled, review 3, it's labeled, and so forth. We have, let's say, m reviews, and they're all labeled. So we use to divide this into training and test pieces. But we are assuming that we have a huge labeled corpus. Now we do not have that luxury all the time, and that's where another mechanism of learning comes in, which is semi-supervised learning. And what do I mean by this semi-supervised learning? That it means that we have a corpus, we have a huge corpus, let's say, uh, of reviews, but not all of them are labeled. So let's say some of them are labeled and some of them are not labeled. See, I would even go on to say that some of them are labeled and a lot of them are not labeled. So what do we do in that case? So let me write this down. It says uh, we have a seed set that's hand labeled. Okay? But what we also have are linkages. Okay? So from some other place, and we are going to be talking about this later in the course. Let's say we have the word nice, and we have these linkages. Okay, there are other words such as the word easy. It has a shorter link. There is another word called funny, slightly longer link, even shorter link, nice, beautiful, and so forth. But we may have other words such as sad, uh, and sad would be slightly closer to, let's say, mean, uh, deadly, dangerous. This is talking about the sadness of these days. And then we have this distance measure of how far this word is from the other word. See how far these words are from each other. So if we can have these kind of distance measures, we can perhaps group these words together and say, okay, let's say there is a small group here, and let's say there is a small group here, and we can say, okay, if one of these are labeled, so let's say this is labeled positive, I think the closer the words are, or the words in the group can also be labeled positive. Similarly, if we have this word sad, which is labeled negative, other words that are close by can also be perhaps labeled negative. See? So this is the sort of trick that we can use in semi-supervised learning if we do not have enough label data. Although you must note that if you have a lot of label data, you should go with supervised learning. This is the case where you do not have enough data and you cannot manually hand label a lot of data, because so that's when you will go with semi-supervised learning and you will see a drop in the performance of the algorithms. So supervised learning algorithms have the highest performance, semi-supervised learning algorithms would have lower performance, and totally unsupervised learning techniques have the lowest performance. See? So this is technique that I just showed you is actually called lexicon expansion technique. in which you can expand your lexicons to domain specific cases. You may have the Senti word net, and you want to specifically expand it for some of the other domains, like, for example, some chat or something. And then you can add words. If you can measure, you can measure the distance between the words in some sort, using some sort of a metric. You can perhaps uh, increase the size of your lexicon or make it specific to a particular domain. Then the other problem is that many a times you have these data sets or the corpus for which you have some labeled samples. You have labeled samples, and they're not balanced. So as we saw earlier, you may have picked this. Okay, we have a lot of positive samples, very few objective samples, and slightly more negative samples. So what do we do? There are a couple of techniques. So there is a technique called downsampling. Let's say you have a huge corpus, then you try to equalize the number of sets or the size of these sets containing the positive reviews, the negative reviews, and the objective reviews. So downsampling, because many classifiers require, such as naive Bayes, they require uh, um similar distribution if you do not want them to be skewed towards a particular class. So uh, if generally the reviews are positive in this ratio, then that's fine. Otherwise, it's going to be skewed because of the prior. So we have a prior, right, that's being multiplied in the naive Bayes, and that's going to skew your reviews or your predictions towards the positive class in this case. See? So there are others that are more sensitive to this distribution. There are other classifiers which are more sensitive to this distribution and would require a similar kind of distribution in all classes. So if that's not true, then their predictions might be skewed. Okay? So there is this technique of downsampling, and there is another technique of upsampling, which is more dangerous. This would be in the case if you have very little data, or as what's required for these classification algorithms. So if you have a large amount of data, you should probably go for the downsampling technique. If you have small amounts of data, then you would go for some of the upsampling techniques, in which the number of samples in the data set or in the corpus are added. So it would generate some newer samples of the negative class, add them, some newer samples of the objective class, and add them to the data. And there are some standard techniques of doing this, and there are some intriguing techniques that you can come up with. And I always see some of these students coming up with these techniques. ठीक है. So that's where I'm going to end today, capping off at some semi-supervised learning. And for these techniques, you can also use semi-supervised learning. And in many cases that you will see down the line in the industry, people will be using semi-supervised learning because of the lack of data, or the lack of data that can be generalized for the entire problem set. So thank you very much. And if you have any questions, you can ask now.